So today is about system development, phases, tools, and techniques. So you know how to develop your HR system. So this is the assignment that goes along with the midterm because we're about midpoint through, so we start talking about software development, systems developments, and stuff like that. So we're going to define, and this is going to be a little overlap for those people who have taken Software Engineering 1, but for business people, you may not have had Software Engineering 1. So this is what you learn in Software Engineering 1 traditionally. Or Systems Analysis and Design, which would be an IS course or IT course. So defining the traditional development cycle, the waterfall model, 7 major phases, comparing and contrasting various different component-based development methodologies, and describing self-sourcing processes as alternatives to software development lifecycle. We have outsourcing, insourcing, and self-sourcing. Couple of different ways of doing or looking at it. And you may pick any of these ways for your HR system as well. Also looking at the importance of prototyping and prototyping and system development methodology. You do not need to create a prototype for your HR system. However, if you wanted to, you could create screenshots if you wanted to. You can do a low fidelity. Instead of, if you don't like charts and numbers and mapping features out, you could and here's what the screen should look like, and because I want to use these drop down menus or I want to use these buttons or something, you can actually map out the screens. If you're building an app interface to this, you're probably going to want screenshots, because it's all about the UI. It has nothing to do with the technology. Apps are all about the user interface. So saving lives through software development, I don't know. This is the Center for Disease Control, tackles a wealth of information. And unfortunately, most of the information is stored in a separate IT system. They don't communicate with each other. So you can put it all together. They're using a service-oriented architecture to integrate. This is actually a real case study. It's in one of the books that this lecture actually comes out of. In the credit for the book is at the end of this lecture. So the Center for the CDC put together this system to bring all the information together, which is actually kind of an interesting thing. If you think about the Red Cross or emergency services and stuff, when there's an outbreak of something, it spreads quickly. So if you don't know, like people in California might not know that somebody in New York got, what was it? Where did that start, actually? We had the, when the meat is on the board, it came through cows. Well, mad cow is a good example. It wasn't exactly the one I was thinking of, but mad cow is an excellent example. You could, if it was all connected together, then you would know that someone got mad cow in New York, or someone got mad cow in California, or they got it over here or over there. And then what would end up happening is that information would spread faster. News like that is certainly in sort of a terrorist biochemical attack, influenza outbreak, bacteria from ponds. I was thinking, like the mosquitoes that send out stuff. Actually, there's a website you can go to that has a database system for it. It was happening a lot with swimming pools, with stagnant water. They were carrying, I can't remember what this disease is called right now, but the mosquitoes were carrying it around, and people were getting sued for contamination, for health risks and stuff. So if you knew it was in your area, you could look at a map and kind of go, well, it's kind of like how people, let's put this out of disease, let's put this into terms of income level and population growth and crime. For example, if I'm thinking about moving to California and I look at a map, I've never been to California before, and I look at a map and I look at East Palo Alto or Oakland, or I look at Santa Clara County, and my criteria is for crime, for a number of deaths per minute or something, or for maybe the scores from local high schools. What are their college entrance scores or their SAT scores average? Then I can kind of pinpoint where I'd like to move to, but without all the data captured together, held together in some sort of an analysis system, you can't see that. You don't know, you just take your chances. Who knew? Oh, I heard from the neighbor that there's a death every 5 minutes in this neighborhood. Oh, and that they sell drugs on the street corner. Oh, I haven't seen them yet, but I'm pretty sure I will. So actually, believe it or not, Santa Clara County, I shouldn't tell you this, it's high on the those people that commit sexual offenders, they have to be registered. high population in Santa Clara County, more so than in other areas, other counties. Apparently, we don't have as many murders here, but we have a lot of sexual predators in this country, in this county. Like almost double some of the neighboring counties, which is kind of scary when you think about it. So, anyway, at least we don't have deaths occurring, like East Palo Alto, actually, or is it? For the longest time, Berkeley was pretty high, but that's gone down. Oakland and East Palo Alto are the more violent areas. So we have quiet violence around here, huh? Richmond is pretty bad, too. Yeah, no, I've been to Richmond a couple of times. I'm not going to criticize Richmond, but Richmond, yeah. Don't lock your doors at night. Don't walk alone. If you're male or female, don't walk alone. Carry a gun and a bulletproof vest. AKA San Jose, I'm just kidding. I'm not getting into that. All right. We do have a heightened security at I2, however. All right, so they're now using, let's go back to CDC. I thought maybe not talking about diseases was going to be a safer topic, but I guess not. So the Center for Disease Control, they're using service-oriented architecture. We just talked about cloud. I mentioned cloud a couple of times. This is cloud technology. It integrates systems and information, and it treats every component of the IT system the same. So a database file, a server, a CRM solution. All of these are little building blocks that work together, so saving lives. So you can apparently save lives through systems development by putting everybody together and making all the information known. So if, for example, that's how the recalls work. You know, if, for example, we haven't had recalls in a while. Several years ago, we had recalling everything. Baby milk got recalled. A bunch of products got recalled. Like, you know, because there was somebody putting stuff in the product that was going out the door. So people do the strangest things. So I guess we're low on the recalls these days. But if there were a recall, you'd find out about it, and you wouldn't buy that product at the store, hopefully. So all computers commonly using binary language, yada yada. Systems development prototyping used to model the proposed system. And outsourcing. Going to another company for system development is a big business. Why would CDC not want to pursue outsourcing? Well, with outsourcing, you have proprietary information and you have stuff that's known to the business. I would outsource some things. I wouldn't outsource other things, as an example. So, which is kind of interesting because there's insourcing and there's self-sourcing. If you're ITU and you've got students all over the place, you self-source. That's where all the interns come from. Most of them, I hope. That's where the TAs come from. You source from within. So you hire people to do stuff from within, or you switch people over. If you're insourcing, you're sourcing inside of the country, traditionally, and these are generic. People use these words in different contexts, but these are generic definitions of these concepts. Most people have heard of outsourcing. You know, it's like where everyone outside of the country gets a job. Out is outside, in is inside the United States, but it's not your company doing it. Self is your company doing it, but you set up another department or you hire the people and you have them work internally. So yourself, you own the technology essentially. So what do we have here? Information system support structure, meeting company strategies. New systems are created because employees request them, usually. And new systems are created to obtain competitive advantages as well. And here's our self-sourcing, outsourcing. So when developing a new system, you have three choices. Three who choices. Who's going to do it? So what you can do for your project is say, okay, you have your HR system. That's really the main first question I'd ask myself is who's going to do it? So if you're going to insource it, you're going to have IT specialists inside your organization. If you have that, because you're going to set the scenario, yes, I have IT support. Well, if we were ITU and we were going to build an employee self-service program, I'd insource it. I'd have somebody at ITU build it. And if we don't have the right person, I'd hire the right person and have them be an employee of ITU. Or you could self-source, do-it-yourself approach. Many end users take little or no help from IT. So you can write your own program. So not really going to happen. So you're probably going to have, well, if you're a business person, if you're a technology, there's a lot of engineering managers who are very hands-on. That's more of a self-source. I also consider, when I look at self-sourcing, I have different definitions, like which I gave you a few minutes ago. And insourcing, I think anything inside the United States. Self-sourcing, anything inside the company. Maybe not me, but maybe somebody that works for me, or I hire someone, you know, like, hey, you be my TA. TA is a self-source, I think, because it's helping me, but I'm working with the TA theoretically, so you know, it's a self kind of thing, or outsource as a third party. But I take outsourcing out of the country, so there's different definitions. So these are some generic textbook definitions from this perspective. So let's talk about software development lifecycle. So, which is kind of interesting. You have to have one for all three scenarios. If you're building it, you're going to have somebody else build it, or you're going to have another company outside the United States build it. Regardless of how you're going to have it built, you're still going to have a software development lifecycle. Software development, okay, this is the lecture for the non-technical people, for the business people, people who have not had software engineering 1 or don't work in software engineering. This is not project management, so the software engineering people need to learn project management, and the project management people need to learn software development life cycles, software engineering. So it's like two of them have like the cross opposite problems. You can totally tell when you see a business person, well, I can totally tell when I have a software engineer who thinks like a project manager. You know, they're not an engineering manager. They're a business manager of some sort. Anyway, long story short, not to get on another tangent, but it's called an Sdlc, Software Development Life Cycle, and it's a model used to develop the software. It's not project management. It's just in the development of the software. So you have a series of phases. You're going to do the waterfall model, which is the traditional model. It came from the Department of Defense. You're going to start in with sequential phases, where you have phase number 1, a feasibility study. I'm just giving you some generic phases. Again, just like with the definitions of in-out and self-sourcing, software development life cycles have totally different definitions depending upon what context you're using them in, with totally different phases. There's no generic set of phases, but there is a common approach to the phases. As an example, I would start out and do, if I were doing a life cycle model following a waterfall pattern, I start out and do a feasibility study, and then I'd come up with a requirements definition, and then I'd do some analysis, and then I'd get a design document, and then I'd implement it, and then I'd do some testing, and then I'd do some deployments, some implementation, you know, on site with integration with the other systems that it's working with. If I were following a traditional model, are the steps really called that? No, you could break the steps out in any order you want. So when you write your HR system, you can develop a software development lifecycle model if you'd like. And you come through, and basically what you're doing is you're outlining a series of steps that you're going to use to create the software and the hardware. It's called software, but it really, can you write software without hardware? Usually they're hand in hand these days. So you don't have to create the hardware systems. You can use the internet. You know, on the Unix server, a hosting company can be your hardware right there. But you're probably going to do a feasibility study at the beginning, and you're probably going to do some analysis, maybe come up with a requirements doc and go through the stages. So it's a step-by-step approach for developing information systems and software applications. 7 distinct phases. Well, again, I disagree with the 7. You could probably make 5 out of them or 8 out of them. It's the way you define them. Also called the Waterfall Methodology. That's the traditional model. It's called the Waterfall. An approach in which each phase in the software development lifecycle is followed by another, planning through implementation. And here's some software phases and major activities. So if you're a software engineer and you wanted to approach this HR system, you could use this as an outline, actually. You could say, hey, we're going to self-source it. We're going to hire the IT department. You know, we're going to send the project over to the IT department. They're going to follow a life cycle, waterfall life cycle. In the first phase, we're going to plan it. And in the planning phase, we're going to define what we need. Maybe do a feasibility study, set out the project scope. What features are we going to stick in here? Because if you just say, build me a HR system, well, that's kind of a loaded, what are you going to put in that HR self-service system? You know, you're going to have major scope creep with that one, because everything in the uncle is going to end up in that system. So you're developing a plan, time frames, and then you're doing your analysis, you're gathering the business requirements, you're designing it after that, you're going to design technical architecture required for the support. You're designing system models, maybe. You know. And then the development. If you're not developing it in-house, then you're sending it out to be outsourced, to be built somewhere else. So building the technical architecture, building the database, the programs that might end up in phase 4 in your development, then testing, and happening after, and then maybe some implementation, and then maybe some maintenance. Yeah, maintenance is actually part of software development, although lately it's like a secondary thing. Actually, testing has turned into a secondary thing these days too. So this approach is what they call the traditional model. You can probably see that there's some weaknesses in here, maybe, if you kind of start thinking about different alternatives approaches to this. This is for a project that would take 1 or 2 years. Is your HR system really going to take 1 or 2 years to build? I hope not. If I were building a major course management system, maybe a year, maybe on that one. But if I'm building an HR system, I'm hoping maybe a couple months, 3 or 4 months maybe at the most. I'm going to spend too much time in the planning, analysis, and design and the development. My 2 or 3 months are going to be done by the time I get to phase 3 probably, which means I'm probably not going to take this approach. Not only that, but at the end, I don't have anything to show until I implement it at the end. So I've gone a year and a half, and I have nothing. Well, the customer thinks I have nothing until I show up like a year later. Oh, are you still working on this? Yep, here we are, 1 year later. Here's your system. Oh, well, we already bought another one. I thought you guys gave up on this. So it doesn't work with cutting edge technology. It doesn't work with fast projects or overnight projects. But if you're building a major system defense program, or you're building an infrastructure, this one makes a lot more sense because it gives you the foundation. So here's the Waterfall Methodology, and this is what I said before. It has stages: planning, analysis, design, development, testing, implementation, maintenance. So you're developing a bunch of stages for it. You could shorten this model by combining the stages and still do a waterfall. It's waterfall because you're going from stage to stage as you go through the development. And the stage to stage component is what makes it a waterfall. Usually, hopefully, you have feedback going between the stages, but you usually only have things going in one direction. If you combine it with a spiral model, so waterfall goes, well, they always say waterfall goes downhill right from the beginning. The project is going downhill, which, actually there's another guy who writes, I can't remember the name of the book, but he says everything falls into the toilet. It's the toilet model, because it just rolls downhill and into the toilet. I mean, it kind of has a connotation of negativity associated with it. So when you get rid of it, so when you throw it, it's an expression. But long story short, this does have that problem. It's realistic. So people have made variations on this. I'm going to save you about 5 or 6 dozen slides by just telling you all variations of this right now. Waterfall goes down. So we can do a big old circle. We're going to take the same steps. Instead of the steps looking like this, we can attach this end to this end, make a big old circle out of it. Call it a spiral model. What does that mean? That means you visit planning, analysis, design, development, testing, implementation, maintenance. Go back up to planning, analysis. You go in a circle, so then you spiral downhill. Because what ends up happening, the problem with the waterfall model just takes too long to deliver anything. Customer doesn't see anything for about a year. Spiral model, it never ends. It just spirals forever. Because when do you get version 1 out of that? You don't. So spiral turned into an iterative approach. Iterative approach means it's a variation of spiral, but you have phase 1, phase 2. You clearly define the iterations. So once you go from planning to maintenance and you come back up to plan, we're done. We got one. And we have beta releases that come out of that. So we have release 1. We get something out of it. So iterative development goes through, iteration. So we have a final product that comes out of each spiral. The only problem is the final product isn't complete. It's only this feature, then we have that feature, then we have that feature, then we have that feature. So a lot of people do iterative development for second releases. So you already have the program out, but you want to go through an upgrade. So you do another rotation through to fix a problem, and then you do another rotation through iteratively to fix another problem. And you just keep working on it forever, because spiral never normally ends. The product is never finished. It just spirals down forever. Goes in a circular fashion. Here has a clear start, and here has a clear end, but it takes too long to get to the end. Then we have rapid application development. Rapid application development says just start right down here. Forget all the other stuff here. Let's just build the thing. Just put something together. Build it. So it's really in the development and the testing and the implementation. In fact, it's implemented before it's even developed. Gmail actually started out that way. Actually, a lot of Google products start out that way. You know, you just throw it out there, it's done. And they encourage that type of development. And you know what? I think it's great, actually. It's fast. If you want to get something out, you want to be the first one out with it, and you want to develop it from an implementation perspective and then see what the users want. So you're looking at your planning, your requirements, your analysis, your design after you've already implemented it or while you're implementing it. So you just stick it out there. I like it. Actually, the only problem though is with some of the YouTube stuff that they come, I don't like it. And the whole G+ thing, I don't like the direction we're going in right now. But you know what? All I have to do is wait, because they'll just flip it around and we'll get in another direction next month. Huh? Socializing. I don't like the socializing direction. Everything is socializing right now. And I'm not a social person online. I don't do that. So it bugs me that everything's linked right now. It just bugs me. Every time I do a Google search, I go, oh, am I logged in as anything? Because they're going to be tracking what I'm doing. And they're going to add me to G+ or my Google circle or something like that. I don't necessarily want to be that social out there. But that wasn't the case last year, the year before, the year before that. Not really. And probably I'm hoping, because, you know, actually now there's features you can turn some of that stuff off. And I'm seeing more turn it off, turn it off. You need to disconnect Google+ with YouTube. It's still connected. I can't figure out how to get rid of it. You need to make it clearer. So that's my only complaint right now. But Gmail started out, I think they were POP, and then they went to IMAP. I don't know, maybe they were IMAP at the beginning, I don't know, but they've grown. They were POP, and then they went to IMAP online. And then for the longest time we had the threading issue. You deleted, I think we still have that actually. You delete a thread, a message, and it deletes the entire thread out of everywhere. Not anymore? Good. These, you know, some people would call these bugs. It's not. It's a feature. So what happened is they implemented it, and then they went back to, what do people want? Let's analyze it now. Let's come up with some requirements. So in the old days, that was my biggest thing. I didn't use Google for the longest time because I kept deleting messages, and then I kept deleting the entire thread of the message. And I'm like, where did all those messages go? And then they made the tagging better, which is good. So I can have my boxes with my tags. And then the stuff goes into my boxes. So then I love that. But none of this stuff existed when Gmail first came out. So none of this stuff for YouTube existed when YouTube first came out either. That's because they implemented it first. Okay, so that's rapid application development. Sometimes they also call it, there's a couple of different words for it. Primarily, it could be a prototyping methodology as well. There's, what do they call it? Agile approach. There's a lot of different words and labels depending upon which reader you're reading, what book you're reading, and which approach you're actually talking about. Prototyping is another kind of methodology used when people want to see something first. So prototyping can be used with Waterfall model. So it's not rapid application development per se, but it's part of it. So for example, if this is going to take a year to deliver something, right around the development, as you're doing the development, after you already have the design, you can do the prototyping. So prototyping has turned into sort of a methodology in itself. So you can take this approach if you want to with your HR system. If you're going to prototype your system, which I mentioned before, you're probably going to make some screenshots and say, hey, this is what I want. So prototyping is done a lot with app development. So in the design, you deliver a prototype to the customer and say, hey, is this what you want? And then the prototype represents the finished product of all the ideas the developers were thinking about. And then the end user goes, oh, no, this is ugly. And then you change it around, you fix it. And you play around back and forth with input and feedback from the prototype. while you're working on the real thing. So the user actually thinks that they have, and they're looking at the finished product. Sometimes some of them actually do think this. And then what ends up happening is at the implementation stage, they go, hey, where's that system you've been working on? The one I've been looking at all this time. Where'd it go? Well, that was the prototype. Here's the real system. And the real system isn't exactly the same as the prototype. It's slightly different. They like the prototype better than the real system. So we have evolutionary prototypes that solve that problem. So the prototype actually turns into the real system. The only problem with that is most prototypes are done in a prototyping language, not in a true development environment. So you're working with limitations. So the finished product that comes from the evolution of the prototype doesn't end up being as feature-rich as it probably could have been because it's designed for a lesser powerful language. So hopefully you're getting the impression there's many different approaches to the software development lifecycle. These are all of the stuff that I've been describing are called life cycles. And there's different takes on it. So if you take Software Engineering 1, you learn about software development life cycles and what's involved. So it doesn't matter how the phases are organized. Most of the phases are about the same, including what these phases I'm going to go through in the next couple of slides here. Planning. Whether you plan after you created the product or you plan before you create the product, doesn't really matter. You still got to plan it. So creating a solid plan for development. This is what you're doing actually with your HR system. Hopefully you're going to plan it. So you're going to find a system, you're going to define the system that you're going to develop. So you can't build every system, so it makes your choices. So you have trade-offs. You also want to look at what's called a critical success factor. So that's a factor simply critical to your organizational success. If you built an HR system and it did not keep employee information confidential, the entire system is worthless. The critical success factor of human resources is confidentiality. If it's a payroll system, it's accuracy. A banking system, accuracy. Student course management system, accuracy. Grade reporting. You want to make sure the grades get reported properly because otherwise you're going to have thousands of students coming back saying, my transcript is wrong. So your critical success factor is definitely the one that's going to make you go out of business if it goes wrong. It makes the system completely unfunctional. So part of planning comes up with this concept of scope, and as I mentioned before, spiral models have a tendency to develop scope creep. That's when you're going around and around and around and around, visiting all these phases, and all of a sudden, wouldn't it be nice to have this feature too? And wouldn't it be nice to have that feature as well? And wouldn't it be, and then all of a sudden, that's scope creep. When the original product you're building now has transformed into something else, and it just never ends because you keep adding stuff to it. Before you're done, you never actually finish the product. So you never release it. So project scope clearly defines the high-level system requirements. Version 1 of the HR Employee Self-Service Program will contain, and I highly recommend you define scope in your planning. Will contain a feature to keep track of employee vacation hours, to keep track of years of service, and keep track of performance reviews, and keep track of yada yada. Make a list of everything you want this thing to do. That's your scope for version 1. And you can also do version 1, version 2, version 3. You don't have to. Just one version of this program is enough. Scope creep occurs when the scope of the project increases. So we're working on version 1 and we decided it's going to have all this, and then the boss comes over and says, hey, you know what? This system has to do this too. Oh, wow, I didn't think about that. And then you spend so much time adjusting to the new feature. And then you come back, well, you know what though? This has to do this as well. And then what ends up happening is you have a creeping commitment, is what they call it, where you can't finish because you keep getting these new things that are added to it. It's just like if I told you you have to write this, but then you also have to include a picture. And then next week I say, oh, you have to put a video in there too. And you have to do a prototype. And you have to, and then it's like, why? I'm never going to finish this thing. It gets too big. It's too complicated. So we have feature creep. Feature creep takes an employee self-service program and turns it into an entire accounting program. Or it also does payroll too, It's like a If I told you that the employee self-service system did student registration, you'd be like, what happened with that? It's feature creep. Now it's like doing everything. It's the entire software package for the entire organization. So it occurs when developers add extra features that were not part of the initial requirements. So now we have, well, actually, it's kind of like the EMS being a social networking system. That's a feature creep. When developers think, don't we need to do social networking? I don't think we need to do social networking. In an academic course management system, we don't necessarily. We have Facebook for social networking. What do we need to do that in the EMS for? That's a feature creep example. I don't believe we're doing that anymore either, which is very good. And in the beginning, a couple of them were thinking about, and then it's the developers, like, wouldn't it be cool? Yeah, it would also be cool to put barcode scanning in there and maybe a little thing to track my exercise, and I don't know, you know, I have a project management tool, and how about this and how about that? So what is this thing we're working with? It's the program. Project scope document is a written definition of the project scope, and it's usually no longer than a paragraph. You can probably define your system in about, 200, 300 words. I'm writing a first version of the HR program. It's going to do this, this, and this. That's my scope. Develop a project plan. Here's the project plan I'm talking about. Includes tasks, resources, and time frames. This is what you're doing for your HR system, but you don't have to use Microsoft Project for this. You can do this in a paragraph as well. So define what, when, and who questions of the system development. Project plan. It says we're going to build it internally. We're going to have our existing computer engineering students do this for a class project. And we're going to have it done by the end of the term. It's going to be their final project. Actually, we need more of that. We need to have a software engineering class build to employees. We can have this class design it, and then the software engineering class can pick the best design amongst everybody and then implement it. Which is actually, believe it or not, a technique that's also used. It's another software development lifecycle model. You have dual teams. I think Google, they do this, don't they? They have multiple people working on multiple projects, all designing the same thing, and then they pick the best. Do they do this? I don't know. So you have Team A, Team B, and Team C. They're all building an HR system for the same company.
That's always how they do it.
Yeah, you're not going to have three.
They throw a project open.
Yeah.
So whoever wants to pick it up, they start working on it.
And then they all start working on it, and it's the one who has the best design that's likable by everybody who ends up winning. The other two, they just go to waste. But it's cheaper to pay people to do it simultaneously.
Actually, no, it doesn't go to waste. We sell it.
You sell it? Oh my god. Actually, that's pretty good. I need to go see what you got, what your extras are. But long story short, you'd think it would waste too much money, but the cost of you hire a team to do it. In fact, maybe that's what we should do with the EMS. Hire like 3 different teams, have them all build an EMS for ITU, and then when they're all done or along the ways, just decide on which one we want and pick that one. And then the rest of them, okay, bye-bye, you go away. Or sell it to another school or something. Because what ends up happening is you can't afford to wait 3 or 4 months and go, oh, this one's not good. And then, okay, you guys are fired, hire a new team. If you do it all at one time, you cut yourself down like, half the project time. It's like immediately reduced to nothing. Plus, also, you get some more competition and creativity, and you get better talent because they're in competition.
It actually helped us in downsizing, reducing the downside.
Yeah.
Downside because they said that at one given point of time, there's always somebody who doesn't have too much of work. So we can use them rather than asking them to leave.
That's an excellent idea. No, I actually like that company. It's pretty good. They have it they're very innovative with everything.
Yeah.
No, there's no
freedom a lot.
Huh?
They give a lot of freedom.
They have a lot of freedom. Actually, that's a good thing if they hire the right people that don't abuse the freedom, that know how to work with the freedom. So.
It's about the culture, even if you are a person who intends to abuse it, but everybody around you does it differently.
Yeah.
Just mesh in.
Actually, I was once working with some guy who totally abused. It never worked. Never did anything. But he would come up with the best ideas, and that was just worth it, just right there. I mean, spent half the time. I don't know what the guy did most of the time, but all I needed him for was like once or twice a year to give me the answer to something. You know, people's worth ethics vary amongst different groups. But, you know, if the person's truly intelligent, there's got to be some value in that. So I think Dr. Real was actually talking about that when he came in here.
Yeah.
I was thinking about that story when he was giving his little spiel. And I'm like, yeah, I know that guy. And why is he here? Who hired him? What is he doing here? He's still on the payroll. But he pays for himself tenfold after, you know, just opens up his mouth for once a year. All right, so phase 1, and then we have some people that don't open up their mouth, that don't say anything. What are you doing here? It's actually not my pet peeve among people, and not talking about my current place of employment, is that, you know, a lot of people like to hold on to information. I have found this elsewhere. It's like it's all in their head. They might be extremely intelligent, but that is of absolute no value unless they share it. So, you know, in a meeting, they just be quiet, and then after the meeting, they go, you know, why didn't you say, why do you wait till now? Or after something has already failed, I could have told you that. It's like, how come you didn't? That person should be fired. I don't care what they know. All right, project plans, project manager is an individual who is an expert in project planning. That's what you are if you're a business person. Define, develop, you're a type A personality. You make a list. You track things. You have milestones. Project milestones. What is a milestone? It presents a key date for which you need to a certain group of activities performed. It checks your progress. If you don't put milestones into your progress, then you don't actually have very much to measure. It's like with people who don't benchmark. Here's the before and here's the after. If you don't know what the before is, how do you know if there was a significant improvement in the after? You know, it's just hard to tell that there's actually any improvement. You don't have to do this, but this is an old screenshot of Microsoft project, believe it or not. It builds a little Gantt chart along with a project task list. Project managers use this all the time to keep track of everything. So at any one moment of time, there was a delay, let's say here, you can use the software, and this is interesting because there's a lot of people that don't understand how to use project. They put it in once, and then they give it to the manager or their boss, and then they go away, and then they just leave it. The thing is, the management software is for the entire life of the project. So up here, when the guy shows up 10 days late, or the piece from China doesn't show up on time, you make a little schedule adjustment and adjusts everything else. So at any one moment of time, you can tell exactly when the project's going to complete. It's not static, it's dynamic. It grows and changes as the project changes. Unfortunately, a lot of people don't know how to use the tool. You know, they think it's static. You just put it together. Here it is. Oh, it didn't work. No, it's not. This is never going to work, by the way. If this works, then you need to do this for a living. Or, you know, you have to sell your services because nobody gets this to work. Even the best plans don't go right. And just think about how long it takes you to get through college. You know, in a perfect world, is it really going to work? Some people are lucky, actually. So it does work. And other people go, oh, they didn't take that class, or that class wasn't offered, or the plan's messed up. So analysis comes after you, so you've done all the planning. And you know what you're building, you got your scope together, then you do your analysis. Well, that usually involves the end users, IT support maybe, understanding and documenting the business requirements for the proposed system. So the analysis says, okay, we're for the HR program. We want to track vacation. Well, do we give vacation to our employees? No. Well, scratch that feature. Or what about employees who schedule vacation but they don't take the vacation? And how do you know how much vacation they're supposed to get? Yada yada. You're looking at the business requirements. You might also be looking at joint application development. If you're building a technology-oriented, let's say you're building a heart monitor, and you're a software engineer and you have tons of experience and you're going to build a mobile app. So the person can look at this is actually out there. The person can look at a mobile app from a little chip that's embedded into one of their ventricles or some piece of the neural system. But long story short, and you can tell, blood pressure's a little high, or stress today, or you can actually tell from looking at the app what's going on. Software engineers are not trained. They don't go to medical school. If they went to medical school, they wouldn't be a software engineer, probably. Who knows? You're not gonna know everything about the technology. So you do what's called a joint application development, or JAD, which means you bring in a medical doctor, or you bring in someone with the expertise, and you hire them for an hour or two. You give them a nice dinner. You put them up. You fly them in for a weekend. You sit them in a room with the developers, and you go, "Where can we stick this thing in the heart?" And the doctor, no, don't put it there. The doctor can tell you exactly what's safe and what's not safe. Should we not give this person an electrical impulse every 5 minutes or something, So you consult, but you don't hire them. They're not part of the development team, but they have an interest. So a lot of companies do this with what they're called the board of directors. This is the classic business case in which they're not running the day-to-day operations, but they're the ones who are going to tell you, oh, you know what, shut down that department. That department's no good. Or you guys are spending way too much money. Or they have an interest because they're usually a shareholder of some sort, or they have a personal stake, but they're not being paid by the company. If you're paying your board of directors, you're doing it wrong. You're not supposed to be compensating them. It's a conflict of interest. You're working for them. They're not working for you. And they're going to tell you, they're going to, advisory boards, committees, these are volunteer normal efforts where they're volunteering for a reason. There's a stake in it. Well, this joint application development might be, these people might be volunteering for a reason as well. Maybe they're shareholders, or maybe they want their name on it. This is the Johnson & Johnson heart monitor, or this is the such and such, So they're going to bring in people to essentially develop a good product. So knowledge workers, IT mates together, sometimes several different days, to define and review business requirements in the system. Make sure that what you're putting together is actually real and works. It's called joint application development. So all this, you get a requirements document that comes out of it. All the planning, everything gives you this requirements doc. You don't have to create a requirements doc for this course or for that project. If you're taking software engineering, you'd put one together. And then on phase 2 for the analysis, take time during analysis to get the business requirements correct. Problem with the waterfall model and a lot of other models, you're basing everything off the requirements, and if the requirements are wrong, then yeah, here it is. We've built it, and then you go into verification and validation. Yes, you have verified that the system works correctly, but no, it's not a valid solution to the problem. It doesn't work. In either case, it's going to be a piece of junk. It doesn't really matter if it's actually built right. So phase 2 is the analysis and making sure that everything's there. So the cost to fix an error in the earlier stages is relatively small. The later it gets, the cost goes up, actually. Which is actually kind of true for the entire project. The earlier you can catch a problem, the cheaper it is, and the faster it is to fix. If you wait too long in the development, wait towards the end, problem is too expensive to fix, almost to the point where you have to start over. And it's technically, maybe it might be technically impossible to fix. And it may also be, obviously way late and past when you needed the software. So in the design phase, you're going to build the technical blueprint for how their proposed system will work. If you take software engineering course, what they use in the design phase is build a bunch of diagrams. So you build an entity relationship diagram if you're building a database, or you build a data flow diagram or flow charts, or use case diagrams. So you learn about all the diagramming techniques in a software engineering class. Again, you don't have to build any diagrams for this project for your midterm. However, if you wanted to build something, you can. It's optional, not a requirement. So design a technical architecture, defines the hardware, the software, the telecommunications, everything that goes into it. And then you can use system models in your design. So it might include a GUI screenshot or so. A lot of people actually take screenshots of the prototype. What I used to love is in the old days when they actually made software and put it in a store, burned it on a CD or a DVD, stuck it in a box, and put the product on a store shelf, like in the old days. And you looked at the pictures of the software, and it didn't match the software that was inside the box. Because those pictures were screenshots of the prototype. Had nothing to do with what was in the box, actually, which is actually kind of funny. And then some of the features that were on the outside of the box didn't match what was in the software, which was kind of weird. And now that everything's all electronic, we don't have that delay. So in order to get something printed for a marketing team, you have to have it ready before the software is ready if you're going to produce it all at one time. Because you're not going to wait for the box to be printed before you deliver your software once you have it ready. So yeah, now we have a little bit more accuracy with that. But that was actually kind of funny. So in the design and system models, a lot of that was the system models you saw in the box. The features that were supposed to be in there, but something wasn't finished. You actually still see that. You see that with pre-released, like they did it with the TV sets. A company wanted to push out those smart TVs. Why anyone would buy a smart TV, I don't know, because it's just like the internet. You just hook a computer up to it and you got a smart TV. But you see these products, this is just an example because it says ready, smart ready. Ready, wasn't it? We left a little hole in the plastic when we made the molding. So you could insert the thing once we actually developed the thing. Oh, so you could put in an external card. Ah. Well, so then they did the same thing with USB drives, and I thought that was actually kind of funny. Like computers had like 6 USB drives. Why do we need so many USB ports on that thing? I still don't understand why we have so many USB ports on. Because we don't know what we're going to use. We just made it ready. It's available. It's ready. It's like, all right. Well, actually, Apple solved a lot of that stuff by putting in the universal ports. And now we have HDMI, universal port, so you can adapt. And then you buy adapters for it. So Apple's big on adapters because they're ready for anything. Well, it's even like the iPod. The first version of the iPod didn't have a camera port. And then 6 months or so later, 3 or 4 months later, then we have a camera port. Click it in there. So now we have USB chart. We have all these accessories. And because the thing was ready, it all works through a single port. But that's something that you're going to do in your development phase in your design. You're going to build that readiness into your design. You're not going to have to do it for your HR system. But if you were building an iPod, as an example, and you don't know what accessories the user's going to need, then you put Bluetooth on there, and then you put USB compatibility on there. And then later on you figure, what are people using this thing for? And then you come up with a bunch of different accessories, or you let third-party people come up with the accessories, as long as you've got the way of expanding it. What I don't understand is why they're still making GPSs. The in-car GPS system? I think it's because people just like to leave them in the car. But all your phones have, and your tablets, everything has GPS on it now. Who in the world would buy a GPS? Well, I bought one a couple years back. Because I don't have a smartphone. I went to a dumb phone instead. But the product never made any sense to me. And now you can buy, for bicycles, you can buy a mount for your phone. And so you can do GPS on your bicycle. I don't cycle that as much so I never had a need for it. But plus, how long are you going to go? How far are you going to go on your bicycle? You need a GPS. I'm going to take it out to Richmond. No, I'm not going to do that. All right, development. The development phase. Take all your design and put it together. Make the actual system. 2 primary development activities. Building the technical architecture and then building the database and the programs. Most applications work with databases. So, as I was mentioning a couple weeks back, the databases are a critical component that needs to be designed as well. Testing comes, well, in this particular, phase 5, not so good. So if you do a rapid application development or you do another, I can't remember the name of it. There's another one, FAST. It's called the FAST model. That's a very old model actually. Then the testing comes first. Let's test it first. So you have product testing, so it verifies the system works and meets the business requirements defined in an analysis phase. I like that you can tell a company that's doing testing first is before the product comes out, you have the service. Would you like to take it? Drug manufacturers do this all the time. Would you like to take this drug? It's a pre-trial test. I don't know if that's really safe, but people do that, and then they go, oh, nope, sorry, it didn't work. And then they don't distribute it. So you write test conditions, and then you go through the steps, and you make sure that the product works, actually. I think somebody's sitting there, but I'm not sure. I could be wrong. I think he might, because he left his sunglasses.
Yeah. Thank you.
It's okay, and you made it before the attendance, so you're in good shape. So performing the system tests, I'll entertain you before the attendance starts. So. We'll talk about Richmond next. All right, so testing. Unit testing, system testing, integration testing, user acceptance testing. So you could take an entire class in testing, and you can take an entire class in QA as well. But in terms of the testing activities, you could add a little paragraph on your HR system if you wanted to and say, this is how we're going to test it. Well, we're going to have 5 employees in the entire company, give them access to this and see if they can do everything they need to do. Speaking of attendance, I think I see the guy at the door. So let's pause. Attendance time? Yeah. Perfect. Perfect timing. I was there. Your ears must be burning. All right, so let me get through this lecture in 15 minutes or less. All right, so testing. As I was mentioning before, we can test at the end, we can test at the beginning, or we can test throughout. It's nice to do it throughout, not to wait till the end. These are different forms of testing. You can take an entire course on testing. Obviously, user acceptance testing happens at the beginning and also at the end. So you can put together a prototype or a user test, and you can actually go through and check it, use it as a checklist essentially, to make sure that this is what you want us to build, and then we go through the system development, and then we verify this is what we have built. And then what we're doing is we're verifying the implementation and the solution that we've created. Implementation is simply implementation. We just implement it. So implementation is not the entire bit of software engineering, and it's just a little piece at the end, actually. But most people, when they think about implementation and outsourcing, that's what's being outsourced. So the problem with outsourcing and the way that it's been done and the failures that have been associated with it is that people think that that's everything. So you need the HR system, so what are you going to do? You're going to outsource it, right? So paragraph number 1, let's say as an example, you say, well, let's outsource it. And then they think, oh, that's it. But you still have to come up with what you want. You still have to come up with the requirements. You still have to come up with the acceptance. You still have to come up with the analysis, the design. You should design a system. Implementation, you're just having them write the source code. So most of the problems that are associated with outsourcing is, especially for software development, is that you're the outsourced company and someone comes to you and says, hey, build me a system. All right, well, what do you want? Oh, just something that does HR. Okay. And then you don't get what you want, and it doesn't meet your needs because you didn't ask for the right thing. So you got an HR system. Or better yet, you go, oh yeah, we'll build you that system. And it's the same system they sold 5 other people. And it's pretty much as useless to you as it is for those 5 other people as well. Which, where's the failure? The failure isn't thinking that that's the entire software engineering solution, and it really isn't. Implementation is just one phase of the solution that you're getting. So even if you tell me in your midterm exam, your take-home, that you're going to outsource it, there's still a lot more you can write about. This is what you're outsourcing right here, the implementation. You're going to come up with the requirements, you're going to design it, you're going to analyze it, and you're going to put everything together, and you're going to outsource it after that. So you can talk about all that other stuff. You can also provide training to the system's users in the implementation phase, which is another interesting thing. A lot of people put together these huge, elaborate PeopleSoft systems. PeopleSoft is, well, actually, now they're not PeopleSoft, but anyway, long story short, they're huge, big systems, or ERP systems, a better way. They don't train anybody. They implement it, they put it in, nobody knows how to use it. If nobody knows how to use it, it's not going to be used. It's like features of software that nobody uses because they don't even know the feature's there, or they don't know how to use it, which is actually kind of the interesting thing with a lot of apps that are out there now, and a lot of features of mobile phones and devices. How did I know that I could connect my phone to my computer and tether it for my internet access? Oh, I don't know. People don't want to explore some of the options. So what ends up happening is the feature will never get used. But if you trained your end user and you gave them skills so that they knew what they were supposed to be doing, then that's a different story, and hopefully they'll be looking at it. So workshop training, online training, all sorts of different things can happen in here. Plus the implementation is kind of an interesting strategy as well. For the HR system that is part of your project proposal that you're putting together for the midterm, you could talk about the implementation strategy. So you have parallel, plunge, pilot, or phased. Well, if you think about the concept is, are you going to take the system out You take the plunge, you just remove the old system and put the new system in. Monday morning, the employees show up to work, and they're going, where's the old HR system? We fired her. She's gone completely, or he's gone completely. Actually, it's a he in our department. So there's no more HR people. They're all gone. Instead, now we have the online system. Oh, it's kind of a plunge. You start with this. You discard the old system. You completely use the new system. Forces everybody to use the new system immediately. It's a bit abrasive to some, and it can be kind of the hard way of doing it. And you might have some downtime because you might have some people who can't figure out how to use the new system. So this gets everybody, the plunge gets everybody on the new system immediately. You don't want to take out the old one, you would keep them running in parallel. Then it's less abrasive, easier transition. Both the old one and the new one are available simultaneously. Then we get the late adopters. We get the people that use the old system forever. And I'm actually that way with devices. If they told me that, oh, this is going to be, your old address is going to be phased out. Here's your new address. Just let me use my new address. Otherwise, I'm going to continue using my old address until one of these days I'm going to have to use the new address. You're just delaying the switch over, which happens in a lot of parallel implementations. Plus, with a parallel implementation, you might have two data sets. The data that's gathered from the old system and then the data that's gathered from the new system. And then what ends up happening is you got to do reconciliation to get all the data put together in the end, because now you got two systems instead of one. Much harder to do, only because you're trying to delay the plunge, trying to delay the initial turnover. Or you could do a pilot implementation. Actually, that's what we're doing with our online program. So we're piloting out this term. Some people got lucky enough to register for, well, there's only one software engineering class, but there was two, but now there's only one. So some students are going, wow, ITU has online classes? Yep, but it's a pilot. Pilot means we have one class from each department. It's stripped down. It's testing it out to see how does it work. Do the students like it? Are they learning the same thing as the on-ground people? So it'll be an experiment for both the student and for the faculty, if you're lucky enough. There's two HR classes. There's two HR classes to be held online, but there's only one engineering and one computer engineering. So it's about 4 or 5 classes total. But you start with a small group of people on the new system, and then you gradually add more users, which means in the spring we'll have triple that amount of classes, hopefully. We'll have like a dozen or so online classes. And then all ITU students can take one online class for their degree program. So don't worry about it if you missed out this term. You'll have plenty more to choose from in spring, actually. And then you won't be working with the first release. You'll be working with a more streamlined class approach, hopefully. We'll have all the bugs worked out by spring term anyway, so you'll have a better class experience, hopefully. So, yeah, a lot of people were kind of bummed. They wanted to take an online class, the data structures class, and it's like it got filled like at 9 o'clock this morning. But unfortunately, you'll have to wait till the spring. But in the spring, I believe I'm going to do software engineering, maybe, and maybe object-oriented programming or something, or some interesting. I'm going to do definitely more than one. Probably do 2 or 3 online classes. I like them better than the weekend classes. I don't have to stand here on my feet, talk to you for 8 hours straight. It'll be much better on my vocal cords. And much better on your, I was going to say on your butts, but on your lower back. Much better on your butts and better on my vocal cords. You can stand up while you take an online class. Actually, you could take an online class from the beach if you wanted to. Or from the golf course. So. All right, so pilot, I won't talk about it more. Okay, so pilot implementation, that's an example of that. Or phased, where you take a piece of the system and you make it part of the new system, and you keep some of the older pieces. So you phase in piece by piece, like a puzzle. Not all programs can be phased. It depends on the application. Most programs can be piloted. Only problem with a piloted is ramping up to the bigger scale. So you have small, and you go from small to large, and that's a huge transition to go in between the two. So, and then also for the pilot, you have a lot of work for 4 classes. Big old infrastructure for a limited number of offerings. It hardly seems worth the effort at this point. However, it will seem worth the effort in spring. So it's definitely has its pros and cons. All these implementation methods do have their pros and cons. And then we have software maintenance, and software maintenance is essentially keeping it running We have monitoring and support of the new system to ensure that it continues to meet the business needs, so we can monitor and change things from two primary activities. Well, one of them might be building a help system to support the end users, and then providing an environment to support system changes and upgrades. Because it might not necessarily be a problem with the system, it might be the design of the system. So if we build a support system in there, then we can gather the user feedback. And we have a support system actually built into the online classes. So we'll get your feedback, we'll know what's going on, and then we'll be able to use that to make improvements for the next term. So if you're lucky enough to take one. So component-based development. So we have the components-based development focuses on building small self-contained blocks of code or components, units, that can be reused across a variety of different applications. So if we do that, we can make new applications on top of old applications because we just combine components. Well, what do we mean by that? Well, these are similar applications. So if you're building, let's say, if you're building a website, you have the component of the network, the space. It's a reusable component. You can put the HR system on there, but then you can also put the database on there, and you can put customer service and a bunch of other systems that can all use the same similar components, perhaps. What you want to do is share components among different applications. Don't think you're really going to get into this for your projects, for your midterm report. You're probably not going to talk about component-based development, but you could. But this small time, if you had a larger application, it could be component-based. If you were building course management system, it could be more component-based versus a smaller type of application. You need a really big application for that. And the focus is on using already developed components to build new components quickly. So that you have to have multiple different applications or interfaces to the same application. So I guess you could put together, it's kind of like how ATMs work, you know, an automatic teller machine and a bank. So they're pretty much doing the same job, but one component's using the other. Actually, it's kind of funny. Well, this is switched. So you go into the bank, you wait in line, and then you swipe your ATM card, and you do everything on the ATM machine. I'm thinking, why did you go into the bank then? You should have just used the ATM machine outside. And actually, it's pretty smart because then, you know, people are starting to realize that I don't go in the bank as often as I used to because I know I'm just going to use the ATM at the window. So, you know, if you're doing a withdrawal, why do you have to go to the bank? Swipe your card. Ask for your money. Maybe if it's above your limit, that might be a problem. So if it's below your limit, you're just getting $20, and this makes no sense to walk into a bank. So, but that's you reusing a component. It's actually going backwards. It's the business reusing an ATM inside for the business for the same process. So a lot of the shopping carts are actually working that way. You go and you make an order. Well, actually, registration, I guess, works that way. You can hopefully register. I don't know. I haven't used the registration system, but you can go into My eye to register for a class, the same as you would do it in paper. Does that work? Yeah. But the systems aren't. I know that the registration systems aren't linked with the EMS yet. I've noticed that, actually. But the components themselves, if you know, designed correctly, should be working. So I'm going to stop here actually because what we've done now, I have finished the software development lifecycle model. It ended with step number 7. And what I'm getting into right now is different development systems or development concepts. So we have component-based, and we have this next one coming down to looking at rapid application, extreme, and agile methodologies, which are different takes on the traditional model, which I just gave you. So if you want, you can look at this on your own, but we're going to cover it picking up next week on this slide here, slide number 30. Talk about more cutting-edge development techniques, and then finish up software development next week. But as promised, it is 3:44. I have 1 minute left. 1 minute before my promise is going to expire. I can just go, yeah. No, I can end it early. But unless we have any questions, we're done for this week, and I'll see you next week. And the midterm's not due till 8/22. And the CSLO, I don't know what happened to it. I will put it back out there. The midterm, I know what happened to that one. I didn't write it. But the CSLO was prepared. I thought it was out there, but it's not out there. So I'll talk about that next week. All right, see you in a week.
Do you want the summary of the midterm?